So, talking about today different kinds of earth materials. And we do these charts. We have a chart, and the chart's going to help us to get the earth materials in some kind of form that we can use it. There it is, decided, right? And we're talking about this form. You can see that we have particles. These things get separated into particle size, moisture content, and the presence of organic content. Rock, it's a continuous mass of solid mineral material. It's the strongest, most stable of earth materials. Structure, the strength varies on the mineral content and the physical structure. Because, there's different kinds of rocks, too. You can't just be generic. It could be granite. It could be a bedrock. It could be sandstone, which is relatively soft. So the rock needs to also be defined. Soil is a particulate, little pieces. Properties vary with particle size, shape, mineral content, and sensitivity to moisture. This boulder is too big to lift with one hand. Okay, so that's a description of a boulder. A cobble can be lifted in one hand. That's why you have cobblestone pavements on old-fashioned Victorian roads, because people could work with that. Gravel, individual particles can be lifted between thumb and forefinger. Okay, I saw that on this quiz. I saw this. Look, on D it says, the smallest particles in the soil can be individually lifted between two fingers. Particles can be lifted between thumb and forefinger. So gravel would be D. You're welcome. Okay, sand. Particles too small. Yeah, I'm talking about this. Individually lifted between fingers. So I guess I want page 1.3 around me as I discuss it. Gravel and cobble. Cobble can be lifted in one hand. Let me look through these questions real quick. A, all the soil particles are visible. Some of the particles are large enough. So here's what I'm doing, ladies and gentlemen. I'm going to go with the questions and then backtrack as we go through this PowerPoint, and then yell bingo when you hit these points. So we'll give one or two possible identifications for the following group. All the soil particles are visible. Some particles are large enough to be picked up individually. That's A. We got this right here. Can be lifted with one hand. That might be cobble, might be A. When dry, the soil seems to be a dusty sand. When weathered, it is still gritty like sand, but the soil sticks together in a ball if compressed by hand.
So A would be sand?
For now, write this in pencil. Because we're going to have to do another thing too. We're going to have to call it what it is, but we might have to pick the specific letter that goes with this. See how that works? Okay, so because it's got first ice and then sand, that's big sand, right? But that just shows you that you're still talking really small. And gravel, you can see a little bit bigger than that. So size here doesn't necessarily, it's just exaggeration. This is, even the gravel is like the size of a penny or a quarter, something like that. Coarse grain soils, there's gravel and sand. Fine grain soils, there's clay and silt. So we want this for our driveway, right? Gravel and sand. Fine grain soils, clay and silt, not so useful for us. The organic topsoils is that green layer, the turf, the peat, the topsoil, and other soils which plant matter and other organic content. So if you're a gardener, this is the stuff that you love because you work with this, and this is where the abundant life is. There's a lot of life in it.
But it's not.
You'll find out you want a little of all this, and sometimes you can't even get away with other stuff getting in there. But you don't want to put your foundation on this. You want a very cleaner soil and something that can take more weight. Topsoil and peat can't take weight, right? So you're going to lose a lot. When all this organic stuff dies, it's going to shrink and it's going to almost evaporate. So you can't use it for that purpose. It's generally weak, unstable, and not suited for supporting building foundations. Okay, so the topic is what do we want to put our concrete on top of? What are we doing on foundation? What do you got there?
So
On top, sands below, we have, yeah. This book makes it easy to work out.
Okay.
Clays, sands, and gravels. And then the nomenclature gets even better. Then we start giving our letter acronyms to it. So group symbol, GW. So let's make sense out of it. It would have to be gravel, W. What would the W be? Gravel well drained. GW, gravel well. GP, gravel poured. Okay, now I'm breaking the code. GW, and then GM is gravel. There goes my theory. GC works, gravel clay, but GM, I'll say has, no, there's no way out. Just memorize. GM. Okay, and then SW is well-graded sand. So sand, well-graded sand with gravel.
SC.
Okay, let's see. Let me
OH.
Coarse grained soils, cohesionless. Strength depends on friction and interlocking of adjacent particles, which is shear strength. When unconfined, have little strength. Coarse grained soil. More pictures. You got a picture?
What letter are we on?
Okay, here we go. I'm still going on a PowerPoint. I have to know the scale, the vastness, and then come back and work at it again. So coarse grained soil. So we're talking about this chart, and we're talking about our coarse grained soils. This is a characteristic we're all in general. There's different grades of those. The properties are little affected by moisture content. Free draining, good for draining water away from foundations and substructures or from under slabs on grade and pavement. So this is perfect.
Which one is that?
Coarse grained soils, it seems to be a perfect construction product because we have free draining. The number one thing you want to do from your house is to get the water away from the structure. And anything that helps in that regard is good for us. So, coarse grained.
What letter is that one for?
Okay, so
That actually answers number 3.
also, properties are a little affected by moisture content. They're free draining, good for draining water away from foundations and structures under slabs. I heard that twice. Let's even go a little bit more denser. We're going to go to fine grained soils. Particle size makes them less free draining, more sensitive to moisture. Properties and strength vary with moisture content. Okay, so clay, very small particles with a larger surface area. Electrostatic forces cause particles to stick together, cohesive. So if you were at the beach and you're like between a beach, you get this kind of structure, right? Because you're working with sand. But if you had clay and you're working a pot, it's going to be able to create these walls. So here, it's evacuation and highly cohesive soil, meaning you could drive your shovel straight down, pick it up, and you would have that vertical wall. But if you did the same thing, you were trying to drive your shovel into a bunch of sand, and you pull the shovel out, it's going to go down to that this angle of incline, right? So that's a little difference there. Clays. Properties vary with moisture content and mineral composition. Some are highly expansive when wetted. Some are virtually impervious to water, and some clays are subject to consolidation or gradual compression over time. Okay, so clay does have a room for us, though. We can make bricks out of it, right? Because these properties are perfect for another application. And they may not be perfect to put our house on, but we can build our house with it.
What does it mean virtually impervious to water?
Water can't go through it. So if
Oh,
a cup,
It doesn't drain.
the water can't doesn't get through it because there's no room, there's no little air gaps. Can somebody show me a picture of the air gaps? That I have that. Okay, someday we'll see the air gaps, but you can see that there are actually gaps in these types of materials. When you're a microscopic scale, you're talking about open openings. Okay, so here's the bucket, and here is how they classify, engineers would classify different kinds of soil. And having more clay content up here at the top, pure clay. Okay, and then sand, pure sand, and then pure silt. And then how these intermingle is where you get something, and we just talked that the loam is good for us. You can have some for building. Liquefaction, when saturated with water and subject to seismic forces, some fine-grained soils will lose all their shear strength and behave almost like a liquid. Another problem, right? If you come at stuff differently, it's going to be more liquid. Here is well-graded soil left and a wide distribution of particle size. Okay, so this well-graded soil has smaller parts that can fit between the structure of larger parts. Well-sorted soil to the right, a limited range of particle sizes, right? It's more uniform. It's more void space and more free draining. So this would be more free, like for a driveway would be perfect understanding of this. If you stepped out on this, there would not be mud, so much mud on your shoes you walk home if you drive over. If your driveway had this, you might have mud packed onto you because of its small size. So having the right kind of soil size is important as well. So that they can carry silty sand, clay sand. So you do have a specialist or engineer will take a look, and usually they already have a kind of soil pre-manufactured, ready to go that you can bring into your site. And they'll also do a soil test where you are, depending on what you're going to dig up. But you can also have different aspects. You could want something stronger, but usually the chart is already made and there's already the ability to bring the soil in. Soils for foundation, we want stability. Generally, coarse-grained soils are less sensitive to moisture content and more stable than finer-grained soils. So we want stability. Further, we want imported soils that are brought in from off-site, general purpose fill for raising the grade. And you see that in Florida where, because of climate change, people are bringing in more soil to lift the new construction houses of almost 1 foot higher, especially along the coast. That's another thing you see. And you can also see that as you drive around the new construction that they're building up the land more. So what happens in slab, gap graded or uniformly graded gravel with good drainage characteristics? Geotechnical reports describe soils and properties derived from test pit samples, boring samples, and laboratory testing. So this goes beyond our ability as designers to choose a lot of this. Usually they don't have a soil sample, they have a soil crew come in to do a test, swatch, to drill several parts on the property to see what you have down